National Electrical Code Article 700 addresses emergency systems. Specifically, Article 700.12 pertains to the fuel supply for emergency generators. It mandates that the fuel supply be located on site and available to the generator without interruption. Natural gas, despite its typical reliability, is classified as an interruptible fuel source. The reason for this classification stems from potential disruptions caused by emergencies like storms, earthquakes, or even intentional acts of sabotage. Such events could compromise the natural gas supply, rendering it unsuitable as the primary fuel source for emergency generators tasked with powering essential egress lighting. Diesel generators offer a distinct advantage in this scenario. These generators store their fuel on site, rendering them less vulnerable to external interruptions. This inherent resilience makes diesel generators the preferred choice for emergency systems that demand uninterrupted power for critical applications like egress lighting. Further reinforcing this distinction is the National Fire Protection Association, NFPA, through its Technical Bulletin TB No. 700-2018. This bulletin clarifies the requirements for fuel sources in emergency generators, explicitly stating that natural gas is considered an interruptible fuel source. Consequently, natural gas is deemed unsuitable for emergency generators responsible for providing egress lighting. The reasoning behind this restriction is rooted in the paramount importance of ensuring a continuous and reliable power supply during emergencies. Egress lighting, in particular, plays a crucial role in guiding occupants safely out of a building during critical situations. Any interruption in the power supply to these lighting systems could have severe consequences, potentially jeopardizing the safety of individuals within the building. Therefore, the NEC and NFPA regulations prioritize the use of fuel sources that offer the highest level of reliability and uninterrupted availability. Diesel fuel, with its on-site storage and inherent resistance to external disruptions, emerges as the superior choice for meeting these stringent requirements. The code requirements emphasize several critical aspects regarding emergency power systems for egress lighting. Firstly, the generator set must be specifically listed for emergency system use. This listing ensures that the equipment meets rigorous performance and safety standards for its intended application. Secondly, the transfer equipment responsible for switching between the normal power source and the emergency generator must also be listed for emergency system use. This listing guarantees that the transfer equipment can reliably and safely transition to the emergency power source when needed. Thirdly, the emergency generator must be capable of automatically starting and accepting the connected loads within 10 seconds of a normal power failure. This rapid response time is essential to minimize any disruption to egress lighting and other critical emergency systems. Fourthly, the emergency generator must be capable of operating at its full rated load for an extended period, typically 2 hours or more, depending on the specific requirements of the application. This sustained operational capability ensures that the emergency systems can function effectively throughout the duration of an emergency event. Fifthly, the fuel supply for the emergency generator must be sufficient to operate the generator at its full rated load for the required duration. This fuel supply must be stored on site and protected from damage or contamination. Sixthly, the emergency generator must be regularly inspected, tested, and maintained to ensure that it is always ready to operate when needed. These maintenance procedures typically include periodic testing of the generator's starting and load carrying capabilities, as well as inspections of the fuel system, battery system, and other critical components. Seventhly, the emergency generator must be located in a well-ventilated area to prevent overheating and ensure proper combustion. The location should also be protected from flooding, fire, and other hazards. Eighthly, the emergency generator must be equipped with appropriate safety devices such as overcurrent protection, overspeed protection, and low oil pressure protection. These safety devices protect the generator from damage and prevent it from operating in unsafe conditions. Ninthly, the installation of the emergency generator must comply with all applicable codes and standards, including the National Electrical Code, NEC, and the National Fire Protection Association, NFPA, standards. These codes and standards provide detailed requirements for the installation, wiring, and grounding of emergency power systems. Tenthly, proper documentation of the emergency power system is essential. This documentation should include detailed drawings, specifications, and operating instructions. The documentation should also include records of all inspections, tests, and maintenance procedures. Furthermore, considering the specific requirements for egress lighting in a school setting, several additional factors come into play. The illumination levels provided by the egress lighting system must meet the minimum requirements specified in the applicable building codes and standards. These illumination levels are typically expressed in foot candles or lux and vary depending on the location and type of egress path. The egress lighting system must be designed to provide uniform illumination throughout the egress path, minimizing shadows and dark spots that could hinder visibility. The egress lighting system must be powered by a reliable emergency power source such as a diesel generator or a battery backup system that can automatically switch on in the event of a normal power failure. The egress lighting system must be regularly inspected, tested, and maintained to ensure that it is always ready to operate when needed. These maintenance procedures typically include periodic testing of the lighting fixtures, batteries, and other critical components. The egress lighting system must be designed to be resistant to damage from vandalism or accidental impacts. A lighting fixture should be securely mounted and protected by durable covers or guards. The egress lighting system should be clearly marked with signage indicating its purpose and location. The signage should be readily visible and easily understood by all occupants of the building. The egress lighting system should be designed to be energy efficient, minimizing energy consumption and reducing operating costs. The lighting fixtures should be selected for their high efficiency and long lifespan. The egress lighting system should be designed to be compatible with the building's fire alarm system. The fire alarm system should be able to automatically activate the egress lighting system in the event of a fire. In summary, providing a 50 kilowatt generator for egress lighting in a school necessitates adherence to stringent regulations outlined in NEC Article 700 and NFPA guidelines. The requirement for an on-site, uninterrupted fuel source effectively mandates the use of a diesel generator, as natural gas is classified as an interruptible fuel. This choice ensures the reliable operation of egress lighting, which is critical for safe evacuation during emergencies. The selection and installation of the generator should also comply with all other applicable codes and standards, including those related to listing, transfer equipment, startup time, load capacity, fuel supply, maintenance, location, safety devices, and documentation.